welcome to Iran. I hope that you have enjoyed your time and experience this time in Iran. First of all, may I kindly ask you to tell me about your experience and visit of our country, and then we will start with the questions.
Indeed, my pleasure, and my pleasure to be here for the third time. And it gets, I would say, better and better every time I get here. I really enjoy the whole atmosphere here. Very nice and kind people, very embracing people. And then there's a special chapter of your food. I simply love your food. So, but also a lot of interesting places to visit. So I feel more and more comfortable coming here to Iran.
How was the training that you had to engage in two trainings?
Two trainings this week, one on 7025 standard for accreditation of laboratories. And I think it was well received. And then when we could dig into the technical details of these standards, there are a lot of things to look into, and we had an additional training on this concept of method validation for methods used in testing laboratories.
And how do you evaluate the level of our participants, Iranian participants, I mean, compared with other experiences you have in other countries?
Well, it's always a challenge to have an open training like this, where people come with very different backgrounds, and they also do here in Iran, of course. But in general, I would say my impression is that, and also from my previous times here, the level of education is really high here. I mean, I have to make my training on a rather high level, not talking about the basics, because people know about the basics here.
Okay, that's not to hear, and I hope that we will see you again in coming years.
I hope so too. I should be so happy to come back.
Okay, thank you very much. Lawrence, welcome to our podcast. As we have already discussed, today we are going to about the quality infrastructure and its role in providing reliable test results. I will start with my first question, which is, let me know what is called quality infrastructure, and what are the institutions involved in this?
How much time we got? Because that's really a big question, but I should try to make it short. We started talking a little bit about laboratories and requirements for laboratories, and that's a part of talking also about quality infrastructure. The quality infrastructure is something which in many countries are more or less now taken for given. It's there without you think too much about it. It's a part of your function of your society. But to try to describe it in more details, it's something which ensures the community that when you go to the markets and buy goods, they are safe for you to buy. There are no health issues related to these products. It's also environmental friendly. And to ensure that, you must kind of wrap both the production of these products and the dissemination of these products, and finally the purchase of these products, into a system where these things are looked into, checked, controlled, and that's basically the quality infrastructure, which is consisting of a number of bodies. And I would say the main bodies there is a standardization body, which is putting out standards, specifications for quality of products, but also for environmental issues, safety issues, and things like that. And of course, in the production, these standards has to be abided to, and that's where companies can be certified to follow, have their quality management system in place, where they can prove that they are abiding to the standards. Still, products from these companies also needs to fulfill some specification, maybe of maximum levels of contaminants or what it could be. So these products has to be checked according to also some specifications, some standards. So that's where the laboratories come in, or inspection bodies who can also do some check of fulfilling standards. Then we have checked the products, and it should give confidence to the client that these products has been checked. But maybe we may even go a step further and say, well, can we trust those checks made by the laboratories? And that's where we first of all must ensure that the measurements done in laboratories are correct. And that's where we put in the third body to the whole quality infrastructure, and that's the metrology institute in a country, which ensures correctness of your measurement. And that's where we talk about these laboratories. When they do measurements, it should be calibrated according to some measurement standards which are provided by these metrology institutes. So we have now the standards, we have the Metrology Institute. I talked briefly about the companies, and they could be certified and they are checked by laboratories. And all these bodies in a conformity, in a quality infrastructure, checking conformity with standards are called conformity assessment bodies. And there are the laboratories, there are inspection bodies, there are certification bodies as the main conformity assessment bodies. Then you can be even more critical and say, well, how can we trust that this is done correctly? And that's where the fourth very important part of a quality infrastructure comes in, that's an accreditation body, which ensures that all these conformity bodies are working also according to some standards. I mentioned in the introduction that we have a ISO 17025 standard for how testing laboratories should carry out their work. And then the laboratory can be accredited by proving that they are following the general requirements in this standard. And that's why we gave a training on it, because I mean there are a lot of details there are a lot of things to be interpreted for the single laboratories, how to fulfill the requirements in such a standard. And the certification body giving certification, for instance, according to ISO 9000, that's well known, also have to be accredited in their work on checking that the companies are fulfilling the requirements for certification. That checking by a certification body must be accredited by an accreditation body, and likewise the inspection bodies must be accredited for what their work. So that's the kind of top level, giving the final assurance that things are okay. I mean, everything is fulfilled. You could think of when you are, well, basically critical about the quality of product out there in the market. It has been through all those processes there. So that's what the quality infrastructure can do and helps with. It should be based nationally on a national quality policy also. From the regulator's side, there should be set up a policy. What kind of quality infrastructure, what should be the levels of the different bodies in the quality infrastructure in our country. And in setting that policy, they should preferably talk to all stakeholders, the producers, the conformity assessment bodies, and the consumers should have a say there in formulating a reasonable quality, national quality policy for your country. And what I've been talking on now so far is taking outset in the consumers in your market. So it sounds like it's only for domestic purposes. But as these national quality infrastructures are related to the international quality infrastructure, I mean, all countries should use, for instance, this 7025 standard for laboratories. So this now linking the country to other countries who also have national quality infrastructures, following the same standards, following the same mechanism, having their laboratories accredited. So if a product is tested in an accredited laboratory in one country, it should be accepted in the country where you export your products to. So this is also crucial for the sake of export. So it's not only targeting the domestic market, it's also the, I would say, prerequisite for a good export and trading business among countries. Having the same quality infrastructure individually implemented in individual countries, but based on the same grounds. One thing I should like to add, finally, talking about quality infrastructure, and that's something which is often forgotten and which may be a problem in some countries, is that you cannot have a well-functioning quality infrastructure in the country if you don't also have some kind of quality culture. There must be a basic understanding of what is quality, and how do you provide quality from the producer's side, and how do you evaluate quality from the consumer side. I mean, in the country I come from, Denmark, there's a nice balanced criticism among consumers whether they want to give that much money for a product or not, because they have a feeling of what is good quality, what is not good quality, and they know that, okay, this is not got good quality, but at least it's cheaper. So this kind of understanding of this, and of course also from the producer side, that they know, I mean, to satisfy the market, they should produce good quality. And this is not only based on standards, it's also based on attitude and mentality and things like that. So it has been more and more popular when we talk about the pillars of a good quality infrastructure, that the pillar of a quality culture is also important in there. That was a short answer to your question.
If you want to summarize, quality infrastructure is there in order to ensure the consumer that the products and goods that they are consuming are safe, are healthy, and they can be rested that the whole system, the whole infrastructure supports their safety and their health. Am I right?
Exactly.
Okay. I know that in your professional career you have been involved in many projects in developing countries in order to help them to establish quality infrastructure. Can I ask you what do you consider as their main challenges and problems they might have in establishing this quality infrastructure in developing countries, I mean?
Yeah. I mean, as you say, I have been in different countries around the world, and I mean, of course, it's a bit different from country to country. But I mean, I think I could identify a few common issues there, and one thing is, and I can refer back to this national quality policy. And a thing which is important here, that when we talk about the quality infrastructure, is that abiding to a standard is in principle voluntary. But you need to do that to be in the market of your product, because otherwise, if you cannot prove by having tested by accredited laboratories and being certified and so on, that you are abiding to standard, but it's up to you. And lately, I should mention that on the side here, that has been also very much talking about a risk assessment approach there. How much do you need to do? You shouldn't do more than necessary, but on the other hand, where do you take off risk of not doing something? So this is the kind of mechanisms there on voluntary basis to abide to the various elements of a quality infrastructure. Coming back to the developing countries, there have been in many of those countries an attitude of putting too many details to the regulatory area. They have made laws on detailed things in production and products and things like that, instead of leaving it out there to the voluntary field of standards and the quality infrastructure. So that's a challenge for some of these countries to kind of lose power of controlling what's going on in their country. So, I mean, I have been in projects where we were really having discussion on government level on how to loosen up for their kind of being in control of everything, and they are giving this out to the voluntary area.
You mean that, sorry to interrupt, you mean that let the market decide what is good and what is bad, instead of going to all the details of regulating and...
Exactly. Mm-hmm. Not that there shouldn't be any regulations, and there's a delicate balance between the voluntary area and the mandatory area, because when it comes to these basic issues of health, safety and environmental issues, of course the country must have some regulations securing that this is in place. But when it comes to the daily mechanism of a society, of production and consuming and so on, it should be left out there to the voluntary field. And then, as I said before, this is based on also some level of quality culture. And that's another challenge in some of these countries. They because probably they have been under this very strict regulated field for many years, they don't think they're allowed to think themselves and have their own opinion about quality. So this change to this more voluntary approach is often a challenge in these developing countries. Yeah, that's my experience. Then, of course, in some minor countries, smaller countries, they have to gradually build up the different elements of a quality infrastructure. And it's quite natural that it starts with the Standardization Institute, making some standards, and then they also add a metrology part, but it's often under the same institution, and eventually also they set up an accreditation body maybe, which is under the same authority, and that's not really good. I mean, probably it could be understood from my explanation of the function of the quality infrastructure before that these institutions should preferably be independent of each other, to have an independent evaluation of whether things are in conformity and so on. So yeah, I think this normal regulated field, the quality culture, and having these bodies being independent, that's probably the three main challenges I have seen in these developing countries.
And my next question is that laboratory results are the basis of making decisions for the conformity of a product. And in order to have a correct decisions, we need reliable test results. What does reliability mean in this context that we are talking about?
Yeah, I mean, first I would confirm that I mean, I think there were some surveys done some years ago by UNIDO or some of these international organizations that, yeah, I think it was about 80%, if not 90%, of all of these conformity assessment activities, checking that things are in accordance with the standard, are testing laboratories. They are really the biggest conformity assessment activity within the quality infrastructure. So, yeah, testing laboratories of all kinds, physical, chemical, microbiological, are certainly a very important tool in there. And you're right, I mean, when they do the testing, they have to do reliable results. And that's because based on those test results, a decision must be made whether your result is in conformity, whatever kind of specification or limit you have to compare with. And to make the correct decision, we can maybe come back to that, what is a correct decision, you must be able to rely on the trustworthiness of your result. And I would like also in this context to introduce the concept of validity, which we are often talking about, because I mean reliability goes on a concept we may talk also about a bit later. That's that when you do test results and you do two test results on the same material, you never get the same result, if you look into the details at least, and that's which can be developed into the concept of measurement uncertainty. There will also always be some uncertainty around your test results. And of course, if you see uncertainty in your test result, and you see two results, is it this result or this result I should use for making my decision? But then the laboratory say, well, we combine and say, well, there is some plus minus uncertainty on our result. And that can make the decision making complicated, because where do I make the decision? But that's how it is. I mean, measurement results are never 100% correct, and you will always have to deal with this issue of measurement uncertainty, and that's of course a major part of talking about reliability. But it's also that you can trust that the laboratory has done best to provide the result. I mentioned before, I have just been given a training on method validation, something where the laboratory must ensure that the method they apply for doing some kind of testing is the best method for the purpose. And we talk very much about fitness for purpose in these cases. And the laboratory must be able to prove that we not only did the best method, but we also checked the performance of this method over time. We compared our results with other laboratories. So they do a lot of things there to prove that, please trust my result. It's reliable and it's valid. So the validity is in place. And that's exactly where the accreditation body comes in, to ensure that the laboratory has done these things to provide valid and reliable results.
Mm-hmm. If we want to make a conclusion, measurement uncertainty, which is a very important parameter showing the maximum possible difference between a laboratory result to the true, so-called true value. Can we say that this measurement uncertainty is the parameter showing how reliable our result is in the laboratory?
Yeah, as I said before, that's probably the main component talking about reliability. But I would also say, well, you may also get results from another method, which may also give low uncertainty, but really it didn't measure exactly what you wanted to measure. So you have to be sure that the laboratory is applying the correct approach in starting testing any kind of material. So that's also a part of reliability, and there are a lot of challenges to that. So to my opinion, it cannot only be expressed in terms of measurement uncertainty.
In 2017 version of ISO 17025 standard, it is noted that when declaring conformity to a specification or a standard, you should apply a decision rule, whether it is specified in the regulations or a standard, or it should be specified in an agreement between the laboratory and the customer. First of all, I would like to know if there are some examples of such decision rules available in regulations or standard, if you may know them. And secondly, please give me your idea about the main considerations we should have in setting such decision rules if they are not available in regulations or standards.
Yeah, could I start with the last question first, because I mean just setting what we understand by a decision rule, and that's very much related to what we just talked about. That this whole setting of the quality structure is very much about this conformity assessment, complying with some limits or specification or whatever it is, and that's the whole purpose of testing, to see if the product is fulfilling the expected requirements and specifications. But then comes in the other thing we talked about, that's a measurement uncertainty. Because, I mean, if there were no measurement uncertainty, everything was just 100% correct, it was easy to see whether a product is below or above a certain limit. If the limit is the maximum value you can allow for instance, some polluting agents or whatever. But we have this measurement uncertainty, saying that we can only give results with some kind of interval around it, some plus minus. And then it becomes tricky, because if a result is just below a limit, well, looking at the measurement uncertainty, the plus minus, some part of the result may actually be above the limit. And what can you then decide? And yeah, decide, that's what leads to the need for a decision rule, how to decide in these situations. And I mean, it has also to do with risk. You know, when you make a measurement uncertainty, a result of the measurement uncertainty, the result is not only the middle of this interval, it's something plus minus. So in principle, the result could be up in the high end of that interval, it could be down in the low end. And if you say the result is below the limit, but some of the uncertainty brings it possibly up above the limit, there is a risk that you make a wrong decision by saying, well, this is under the limit. It might not be. And that's why you have to consider what kind of risk are you willing to take, and based on that, make your decision rule. So setting up a decision rule takes, or I would say, making a decision takes, of course, that you do the testing, you know what you're testing for, you know your measurement uncertainty of that testing, you know what kind of limit you are comparing it to, and then you must have your decision rule to make the decision correctly, especially in those cases where you are close to the limit. And then come back to your first question. Yeah, I mean, over time, I would say, unfortunately, there have been not too much thinking about this. People have just saying, well, if the result is below limit, then it's fine. But the awareness of this issue of measurement uncertainty has become more and more prevailing, and people have been more and more aware that, whoa, we have to be careful here in making our decision. And gradually, these rules for making decisions has also come into regulation. A lot of these, as I said before, I mean, we have the voluntary field, the standards and so on, but still there are a number of issues under regulation also. For instance, in the food area, for the health, for the sake of securing health in your population, you set up some regulations there, and yeah, some of them are applying some decision rules now. I cannot refer to all of them, but I just recently came across one where you talk about residues of pesticides in vegetables, for instance. And at least in European regulations, which I can refer to, there is a regulation saying, well, when you test this, your result, only if your result is above the limit, including the measurement uncertainty around that, you have too much pesticide in this. So that's a rather, you could say, from the producer's side of view, a rather wide decision rule, because you can even exceed the limit, including measurement uncertainty. So that's why one way of expressing. In other cases, you want to be more cautious, more careful. Then you say that you can only accept accept a result if the result, including the measurement uncertainty, is below the limit. So that's one example I could think of. Yeah.
You mean that we can find only in sensitive areas such regulation recommended decision rules, otherwise it has to be agreed between the laboratory and customer considering the risk of
it has very much to do with which risk you are willing to take. You will find also areas where there's no talk about measurement uncertainty. For instance, the pharmaceutical area, you often find that you just have to be below a certain limit. But it's because they have put this kind of, we call it a guard band, around the limit, already saying, well, to be below limit, you should not just be below the limit, you should be a certain level below the limit, taking into account that there is an uncertainty on your result. So that's another way of expressing it. And yeah, if there's no written standard or specification or regulation on the field, the single client to a laboratory should be aware of this and discuss this with the laboratory. And sometimes the client asks the laboratory to make these decisions in their report. It's not always the case. Mostly, I would say, laboratory just provide the test report to the client, including the measurement uncertainty. And that's another debate whether clients really want this measurement uncertainty. They should ask for it, because that contributes to the reliability of the result. And although it makes the decision more difficult, they have to consider risks and things like that, it will eventually be a more correct decision, because they cannot neglect the issue of measurement uncertainty. But in those cases, the client should go into communication with the laboratory, say what kind of risk are we willing to accept here, what is the measurement uncertainty level on this kind of test, and based on that, decide how much should a result be, say, below a limit, taking this uncertainty into consideration. And when this is agreed, then this can be done also by the laboratory, although it's basically the client who is going to make the decision. It can be helpful for the client to see the laboratory make this kind of decision in the report based on the decision rule, a clear decision rule, also identifying the risk which is in there. There will always be a risk. Nothing will be 100%.
In 2017 version of ISO 17025, a new term, sampling uncertainty, has been introduced, which is a very important factor in some cases, especially cases which we have some heterogeneity in our sampling target. And many labs ignore such a factor in overall uncertainty, and they have not been involved in evaluation of such important factor. How this matter should be handled, and what would be your recommendation for the laboratories to consider sampling uncertainty? I know that it is too complicated, and it is not. There is no one single solution for different types of labs, but I really appreciate it if you can.
Yeah. I mean, I should try to make a brief answer to, again, a very big question. You're right. There has, since the issue of this latest version 3 of the 7025 standard, which is setting the requirements for testing laboratories, there has been a big debate around this because of the introduction of this concept of the uncertainty coming from the sampling part of a testing. And it has been more or less deliberately overlooked for too many years, because what we have been talking until now on regarding measurement uncertainty is the variability of results from test methods inside the laboratory. And that contributes to a plus-minus value on your final result, the measurement uncertainty. But that test is done on a sample brought to the laboratory, taken from out there, from a production line, from a lake with some water, some polluted soil, from a production line. And you mentioned the concept of heterogeneity and lack of homogeneity out there. So can you be sure what the sample or the few samples you are taking are really representing that whole production, that whole lake, whatever you're taking the sample from? And in addition to that, the handling of the samples, the taking of the samples, the transportation of the samples, the containment of the samples on its way to the laboratory, it may lose its characteristics. It may not really be representative of where you took it anymore. And so when eventually the sample comes to the laboratory, you really have to judge. I like to use the word the validity of the sample for testing. We talked about the validity of test result for making decisions. Here I would take it a step backward and talk about the validity of the sample for making tests on those samples, because if they are not really representing the original material anymore, it's waste of time and resource to test them, because you will not be able to trust the result anyway. That's a big challenge, and because measurement uncertainty, well, as the concept says, it's based on measurements. And until you have the sample tested in the laboratory, there haven't been no measurements done. So how can you talk about measurement uncertainty out there in what is going on preceding the test in the laboratory? So that's the challenge. We have recently, maybe I should briefly mention that I also represent this European organization called EuroChem, which is dealing with a lot of these issues related to quality management in laboratories and quality assurance in laboratories. And we have recently started a working group on trying to dig into this and see if we can come with some guidelines on improving that situation of the validity of those samples brought to the laboratory. And of course, if you could see the whole testing process as one big process, from the sampling to finally issuing a test report, then you could somehow quantify the uncertainty of that whole process. And it proves that the uncertainty contribution coming from the sampling part is mostly much bigger than the uncertainty coming from the laboratory part. So it should be considered, although it's really a big challenge. You can make some big experiments where you can actually quantify this. But for the many situations where you do sampling and testing, oh man, it's a big task, and also because mostly the sampling activity and the testing activity are rather separated at the laboratory door, as we say, because somebody's taking the sample and bringing it to the laboratory door, and from there on, the laboratory takes over. And actually has been a little bit taken care of this in this 7025 standard we have been referring to now several times, that it says that when you report a result, you should normally make a disclaimer saying that the result is only relevant for the sample brought to the laboratory. It cannot be seen as a result for the whole, whatever kind of material you took the sample from. And then they leave the responsibility to those taking the sample of the client to, whoa, how do we handle that? So the discussion has just started. Well, yeah, it's 5 years ago now since the new version of the standard came out, but it's still a big discussion, and it's still a big challenge for many laboratories. But I should say it should also be a challenge for those doing the sampling. And sometimes the sampling is done by the client who is not really knowledgeable about these issues and not thinking about what could spoil the whole picture and eventually make the final result unusable for making decisions. So there will be a lot of discussion around this in the year to come. They are having now the discussions, but they will go on for quite a while before we find some reasonable solutions to this.
Okay, thank you for your explanation. My last question is about sampling uncertainty again. I have had an experience in a lab that they were dealing with a very heterogeneous sampling target material, and they were in charge of sampling. And when they calculated the sampling uncertainty, they also had a very small testing uncertainty. But when they combine these two, the overall uncertainty is too high, and when they report it, they said, okay, sometimes our customers come to us and say that, why are you so uncertain about your testing? And they said that we prefer to separately report. This is the contribution of testing uncertainty, this is the contribution of sampling uncertainty, and we are not going to combine them, so in order to assure their customer that what is happening in our laboratory is good, but with low uncertainty. How this can be handled? What is your recommendation for such situation?
Well, going back to the discussions I mentioned before, because in principle, I think it's stupid to close your eyes saying, well, there's no uncertainty out there in the sampling. Yes, there is, and it is big. And also the clients have to realize that. So as I said before, there will be a lot of challenges and discussions inside the laboratories. But they need to involve also the clients, the consultancy companies, the construction companies, whoever are making use of test laboratories. That there is an issue there they must be aware of. And I mean, I have been consulting a laboratory who was doing tests on building debris. And that's certainly some inhomogeneous material like any. And there were uncertainties. I mean, we talk about plus minus, but also sometimes we express it in percentage. And there were uncertainties of 100% because of that. And I mean, how can you use a test result with an uncertainty of 100% for making a decision? But on the other hand, if that's the case, you need to accept that that's how it is. Or maybe you can improve your sampling approach to see if you can lower that uncertainty, but it's really a challenge in some fields where especially where you have this very heterogeneous material as a starting material. And that's the technical solution, if we will ever find that, to this. But I think a very big part of this is also the awareness of, the acceptance of that there is something called uncertainty. There is some plus minus there, and when we talk about sampling, it's a rather big plus minus.
Okay, Lawrence, thank you very much for your time. It has been a pleasure for me as always. And if you would like to add your final comments to our interview, I would be appreciated. Otherwise, we can finish now.
Well, maybe I could make a comment going back to the very start of this, the introduction of my impression of work here in Iran. That, yeah, I mean a lot of very skilled, very well-educated laboratory people here. And I do hope that Iran will also make a good. I'm not so much aware of that. The whole quality infrastructure overarching the work in the laboratories. That gradually also will be a good national quality infrastructure in Iran. And if I can be used to give more trainings on some of these issues, I should be happy. Thank you.
Thank you very much. I hope that you enjoy the rest of your trip in our country.
I'm sure I will. Thank you very much.